All right, so thermal physics. Here's just a quick review. Remember from chemistry, PV equals nRT. P is pressure, V is volume, N is the number of moles, and R is the gas constant, the universal gas constant. And T is temperature, and it's in Kelvin. So don't forget about that guy right there. Now when it comes to thermal processes, we can mark them with a like with a graph. So let me make a little graph here and we'll go through some of the processes. First, I want to look at a PV diagram, and let's look at an isobaric. So isobaric, and that would be when the pressure doesn't change. So maybe those are two ends, and it can be the process can have an increase in volume or a decrease in volume, so it can go left or right. So this is called isobaric. Now, the work done, if work is force times distance, and volume can be related to distance because volume is length times width times height, so there's a distance in there. The short answer is the work is the pressure times the change in volume. And this is the work done by the gas. So when the gas expands and it pushes on the environment, it is doing some work because it's pushing something, and it's going to change that something's kinetic energy or its position. So if you imagine a canister of gas and it expands and it pushes a piston up, well then it can give something potential energy. Now if we look at the work done on the gas, and that's the vocabulary, that's the preposition that's used on the AP exam. The work done on the gas is negative P delta V. And that's the one you'll see on the AP exam, and that's the preposition. The difference is the by versus on. So by is the work done by the expansion of the gas, where on means that in order for the gas to do that work, it has to lose some energy. Some energy has to be transferred from the gas system to something else. So when a canister of gas expands out, it's going to have a change in energy. Its change in energy is going to be negative because it has taken some of its energy and transferred it to something else. That's the difference in by and on. Okay? Now, for this one, the volume increases or decreases, and you can have the work done on the gas could be positive or negative depending on the change in the volume. Okay, so for an isovolumetric, let's put pressure over here on the y-axis, volume on the x-axis, and this process would look something like this, where either you increase pressure or you can decrease pressure, but the volume stays the same. Okay? That is the definition of iso, same, constant volume. The first law of thermodynamics is delta U is equal to Q plus W. Alright, so the first law of thermodynamics, delta U equals Q plus W. So it's a change in internal energy is equal to the thermal energy added to or removed from the gas and the work done on the gas. So if there is no change in volume, tell me about the work done on the gas. So then the first law reduces to, so the change in internal energy is equal to the thermal energy added to or removed from the gas. I'm going to go ahead and stop this.